So hello everybody, how are you? I hope all of you are doing good. So how are you guys? So let's start today's session. As you know, today is a Vishwas Divas, so be ready for the Vishwas Divas. So all of you be ready today, as you know, the Vishwas Divas. So don't worry, I'm going to wind up this session soon so that you can attend the Vishwas Divas and enjoy this session, right? So those who don't know what is today is a Vishwas Divas of PW. Right. So be ready. So there will be so many surprise on the Vishwas Divas, right, for you guys. So let's start today's session. Here I'm going to start some question, right? Here I'm going to start this session with some question, and I will try in this session that I'm going to cover these topic like the cutting shear strain, velocity in metal cutting, shear strain rate, and uncut chip thickness and width in turning. But before that, before that, today I'm going to solve some questions, right? So be ready with some questions. So here I'm going to start some question. So these are the question. Yes. So my dear student, let me know the answer, right? So here I'm going to start a clock. Yes. So your time starts now. Tell me the answer. Here, Jayesh Patel says that option C. Okay, Jayesh Patel says that is option C. The question says for cutting of brass with a single point cutting tool on a lathe, tool should have which tool? Which tool? Yes. So Judge Patel says that the option is what? C. How many of you them are saying that the option is C? Yes. Okay. B. Isn't it? The B. B is the correct answer? Yes. Tell me the answer. Is B is the correct answer? Let me see that how many of you them are going to solve this question. Somebody says B, somebody says right, somebody says what. Let's see that how many of you them are going to give the right answer. My dear, brass, generally brass because the sharpest. No, the reason is not correct. The reason is not correct. Whatever the reason Alok Kumar you are saying, the reason is not correct. For cutting of brass with a single point cutting tool on a lathe, tool should have what? The reason is not correct. The reason is not correct, my dear. Okay, the reason is not correct. Good. Now I will tell you the answer. Now your time is over, right? So yes, for cutting of brass, my dear, right? For cutting of brass with a single point cutting tool on a lathe, tool should have zero rake angle. First of all, it will be zero rake angle. So your correct answer is your option B is the correct answer. Your option B is the correct answer. My dear, always remember that the brass and cast iron for machining for for machining for machining of brass, okay, and cast iron use zero rake angle. Zero rake angle. Use which angle? Zero rake angle. Right? Use zero rake angle. Is it clear? Use which angle? Use zero rake angle. Right? Use zero rake angle. Right? The thing is very simple that okay, generally basically zero rake angle will be used in the form tool, and there is an exception. This is an exception that for brass and cast iron we use a zero rake angle, right? We use a zero rake angle, right? How to come zero rake angle? My dear, it is a strong tool, right? Sorry, it is a strong material, okay? And in zero rake angle tool, the supporting material is more compared to what? Positive rake angle. The tool is little bit stronger. Now you can say, sir, we can use also negative rake angle tool. My dear, negative rake angle tool is not required because here material is not so strong. Negative rake angle will be used in the case of alloy, right? Negative rake angle tool will be used in the case of alloy and higher alloy, and brass and cast iron not of higher alloy category. They are not belong to the higher category. So brass, although brass and cast iron hard, right? So positive rake angle, there is a tendency that positive rake angle will be break, will be fail while cutting a brass and cast iron. So compared to positive rake angle, we recommend zero rake angle tool, right? We recommend zero rake angle tool. Is it clear to everybody? Is it clear to everybody? Is it clear to everybody? Vishnu says of positive rake angle material. Okay, how to come zero rake angle? I told you now, Vishnu. Why the positive rake angle? Because zero rake angle is comparatively having a high strength compared to positive rake angle, right, Vishnu? So I hope you understood the answer. So option C is the correct answer, right? Option C is the correct answer. Now, next question. Which one of the following statement is not correct? Which one of the following statement is not correct with Vishnu? If you want to see the example, please go to my previous video. You can find the examples also, right? I thought today is the first day, right, in this lecture, and we are covering the fourth lecture of this session, right? Yes. Question number, the second question is, please tell me the answer. Yes, please tell me the answer. Your time starts now. Your time starts now. Please tell me the answer. Please tell me the answer. Which one of the following statement is not correct, right? What is asking? Not correct. Not correct. Which of the following which one of the following statement is not correct with reference to the purpose and effect of rake angle of a cutting tool? Yes. Yes. And effects of rake angle. Which one of the following statement is not correct? Yes, tell me. Yes. Yes, tell me, please. Okay. Here, Rajat Sharma says, sir, option A is the correct answer. Let's see how many of you them are going to give the answer. Yes. Here, Patel says that option D is the correct. Okay, I'm going to write also the answer. Rajat. Rajat says, sir, answer A. And Patel, Cure says that option. Q says that option B, right? Q says that option B. Am I right? And here Vishnu says, sir, option D is the answer. Okay, let's check the question, right? Let's read out the statement. Okay, please see. Which one of the following statement is not correct? I mean, he's asking which statement is not correct with respect to the rake angle of the tool. My dear, to guide the chip flow direction, basically, this is the rake angle, right? This is the rake, this is the tool, and you know, this is what? This is, this is what? This is, right? This is, this tool is going with this velocity, and this is a positive rake angle. And you know, because of the rake angle, the cutting velocity is maintained. So this statement is right, but is asking not. So this statement is right. So this is not our answer. Now, to reduce the friction between the tool flank and the machine surface, let's see. Okay, to add the keenness of the or sharp to the cutting edge. My dear, this option, the statement is right. As you know, positive rake angle is more sharper, right? Compared to zero rake angle, compared to zero rake angle, and zero rake angle is more sharper compared to negative rake angle, right? And because of the rake angle, the flow of the chip changes. Look, because of the rake angle, the flow of the chip changes. Here, zero rake angle, zero alpha. This is negative alpha. Here flow direction of the chip changes. So statement C is right, but he's asking not. So this is not our answer. So my dear, I hope statement A. Rajat, so A is not the answer. Right, Rajat? Rajat, A is not the answer, my dear. Rajat, A is not your answer. So your answer is wrong, Rajat. Right? So let me eliminate the option of Rajat. Rajat, your answer is wrong. Now, to provide better thermal efficiency, to provide better thermal efficiency, to provide better thermal efficiency, this option is also wrong. Why? I mean, the statement is right. My dear, tool rake angle changes, tool rake angle changes, then the supporting material, then the supporting material behind the cutting edge changes or not? Tell me, Vishnu. Your answer was D. As the tool rake angle changes, supporting material changes or not? Vishnu, tell me. Vishnu, tell me. Sir, please load. What load? Yes. What he says, to provide better thermal efficiency. Vishnu, as the rake angle changes, the supporting material changes. You know, behind the cutting edge, Vishnu, behind this is the cutting edge. This is the cutting edge. Behind that point, there is a cutting edge. Behind that point, there is a cutting edge. Right, Vishnu? Here, tool supporting material. In every positive rake angle, supporting material is less. Zero rake angle, supporting material is large. And in negative rake angle, supporting material is more. Right. Sir, increase your audio loudness. My dear, my audio has the limited. Uh, I think this audio is good enough for you. Now, my dear, if the supporting material increases, as you know, Vishnu, in the cutting operation, heat is generated. Yes or no? In the cutting operation, heat is generated. Yes or no? Tell me, Vishnu. In the cutting operation, heat is generated. Yes. If heat is generated, so where the heat will go? The heat will go either into the heat will go either into the chip, either into the tool, okay, either into the chip, either into the tool, and either into the workpiece. Right? The heat will go either into the tool, either into the chip, and either into the workpiece. My dear, better thermal efficiency means here supporting material is more, so that tool can withstand at higher temperature, because that tool can absorb large amount of heat for a longer time period, Vishnu. Yes or no? For a longer time period, Vishnu. So as you change the rake angle, thermal efficiency of the tool changes na. As you change the rake angle, thermal efficiency of the tool changes na. Yes or no, Vishnu? So this statement is right, but he's asking not. So this is not our answer. So Vishnu, your answer is what? Wrong. Now the remaining option is what? B. So B is right. My dear, what he says, to reduce the friction between the tool. My dear, this friction get reduced. The friction between the tool and surface of the workpiece, to reduce the friction between the tool flank. This is a flank, as you know. This is what? This is flank. This is what? This is flank na. This is what? This is flank. Right? This is flank. As you know, this is flank. So friction get reduced between the flank. Friction get reduced between the flank and the workpiece because of clearance angle. Because of clearance angle. Because of clearance angle. So this statement is wrong. So this is our answer. So Kior has given the right answer. Right? So Kior has given the right answer. Very good, my dear. Now let's move to the next question. Yes. Yes, tell me. Explain magnetic field. What are you asking, Himanshu? Here I'm not teaching 11th, 12th class, right? Here you are learning the concept of what? The concept of engineering. Here magnetic field is, what is the role of magnetic field? I think you joined the wrong lecture. You have joined the wrong session, Himanshu. Yes, tell me the answer. Explain power consumption in turning can be cutting power consumption in turning can be significantly reduced. How can you reduce the cutting power consumption? How can you reduce the cutting power consumption? Yes. How can you reduce the cutting power consumption? Here says that answer is here says that answer is A. And anybody else? Patil says Jayesh Patil. Jayesh also says option A. Let me see. Rajat. Rajat also says option A. And Vishnu also says option A. So no doubt everybody is saying option A. So yes, option A is the right answer. As you know, if you increase the rake angle, then cutting force decreases. Now, what is the power? Power is cutting force into cutting velocity. So, power decreases. It means that cutting force decreases. It means that your power consumption goes decrease. So, option A is the right. Very good to all of you. Very good. Now, let's move to the next question. Let's move to the next question. Yes, so your time starts now. In ASA system, if the tool nomenclature, basically it is in degree, 8 degree, 6 degree, 5 degree, 5 degree, 10 degree, 15 degree, okay, and 2 that is a nose radius, right? Now tell me, the side rake angle is which book, which book represent for production, which book represent? Beta, which book you want to study? You can study many book like you can go to the PC Sharma, PN Rao, right? These are the good books for your competitive purpose, right? They solve your competitive purpose, right? Yes. So let me see what is the answer. The side rake angle. He is asking what, my dear? Side rake angle. So, do you know the ASA nomenclature? ASA nomenclature, right? ASA nomenclature. So, back rake angle, side rake angle, back rake angle, side rake angle, right? Back rake angle, side rake angle, end relief angle, side relief angle, end cutting edge, side cutting edge, nose radius. At the second place, 6 degree is the right answer. So, option is what? B. So option is what? B. Option is what? B. Very good. Now, please solve this question. First of all, tell me, before that, first of all, tell me, today is 28th of Feb. Do you know what is today? Today is 28th of Feb. Yes. Today is what? What is the today's date? What is the date? Today is what? 28th Feb. What is special today? What is special today? How many of you them? Yes. Science Day. Yes. Yes. In PW, in PW, in PW, today is the Vishwas Divas, right? So very soon on the on our PW channel, Vishwas Divas is going to be celebrate, right? So I'm also hurry to join the Vishwas Divas. I also want to know, I also want to see what is going to happen on the Vishwas Divas and what are the surprises for the student. So I'm also very curious to join the Vishwas Divas. So that's why today we are going to wind up our lecture very soon, right? So that we can we all can enjoy today's Vishwas Divas, which is going to be very soon start on our YouTube channel, right? Is it clear now? Is it clear to everybody? So today we are going to wind up the session very soon so that we all can join that session on YouTube, right? Okay. So, yes, let me, yes, please tell me the answer. Please tell me the answer. Yes, please tell me the answer. Yes. So you can use your calculator if you don't have right now. You can use your calculator if you don't have right now. Please take your calculator and solve this question. Please take your calculator and solve this question. Please take your calculator and solve this question, my dear. Please take the calculator and solve this question. Yes. So Rajat says that option D is the right answer. So let me write down who is giving the answer. Rajat say option D. Anybody else? Rajat changed the party and he say option A. Rajat changed the option and now he's saying that option A is the correct answer. Yes. Anybody else? Yes. Anybody else? Yes. Anybody else? Kior says option A. Here, Kior also says that option A. And Jayesh also says that option A is the right answer. Okay. So, shall we solve this question? Yes. My dear, during orthogonal cutting mild steel with 10-degree rake angle, so it is given that alpha equal to 10 degree. The chip thickness ratio, that is R, was obtained 0.4. The shear angle you have to evaluate. All of you know that in the yesterday class I told you tan phi equal to R cos alpha 1 minus R sin alpha. So here phi equal to tan inverse, right? R, that is 0.4 cos alpha, that is 10, divided by 1 minus 0.4 sin 10. Yes. Yes. So you have to calculate and I think you will get the answer of what? I think the option A will be the right answer. Let me calculate. Here shift 10 inverse 0.4 into cos of 10, right? Cos of 10 divided by okay, cos of 10 divided by 1 minus 0.4 into sine of 10, right? So 22.94. So it will be 22.94. The right answer will be 22.9. Very good. So all of you have given the right answer, right? Very good. Very good. Right? Very good, Rajat, Kior, and Jayesh. Congratulations to all of you. Now, let's move to the next question. A single point. Yes. Yes. Let's move to the next question. A single point cutting tool with rake angle 12 degree. With rake angle 12 degree. That is alpha equal to, I think, 12 degree. Yes. Let's solve the question. Yes. Yes, please solve the question. Yes. Are you people there? Yes. Hello, everybody. Few minutes more. What's the answer? Cure? Jayesh? Vishnu? Rajat? The when Vishwa today, Rahul. Today is a Vishwas Divas. Today. And very soon on our YouTube channel, on PW YouTube channel, the Vishwas Divas is going to live on PW YouTube channel. Vishwas Divas is going to live, my dear, within a few minutes. Let's within a 10 to 15 minutes. The Vishwas Divas is going to be start. So it's my request to all of you, please join today's Vishwas Divas. Right, there are a lot of things for you students. Right, I'm also curious. I'm also going to join this session. Right, not PW sir on Gate Wallah for Gate Aspirant. My dear, it is basically it will be live on the all channel. Right, it will be live on the all channel. Right, it will be live on the on channel Infinity. So you are saying that option B. Okay. Let me check. Here rectangle is given 12 degree. The depth of cut, that is uncut chip thickness, that is T naught, is given 0.81 mm. Right. The chip thickness used under the orthogonal cutting condition, that is TC. It is 1.8 mm. Now the chip thickness ratio, that is T naught by TC, equal to 0.81 divided by 1.8. Right, 0.81 divided by 1.8, it is equal to 0.45. So phi equal to tan inverse r cos alpha 1 minus r sin alpha. Right, so phi equal to tan inverse r is what? That is 0.45 cos of alpha. Right, cos of alpha, yes, cos of alpha, that is what? 12 divided by 1 minus 0.45 sine of 12. Right, so answer into cos of alpha, right, divide by 1 minus answer into sine of alpha. Right, shift tan inverse answer. So here comes the answer. It will be 25.901 degree. So B is the correct answer. Right, everybody? B is the correct answer. Now let's move to the next question. Yeah, it's a very good question. It's a very good question. Very good. Please solve. Yes, please solve. So don't forget to join today's Vishwas Divas. Okay, you will get the link on our Gatewala channel and other channel also. You will get the Vishwas Divas link, right? You will get the Vishwas Divas link. Let me see whether it is started or not. Let me see whether it is started or not. Uh, so here I'm not able to find the link. Let me see from where you can join. Yes. So yes, Vishwas Divas is going to. I mean, it will be. It is going to start at 8 p.m. today, right? The class ka notes not available. Beta on the app it will be available. Vishnu. Vishwas Divas is going to start on 8 at 8 a.m. right? Today at 8 a.m. right? Vishwas Divas. You can join the Vishwas Divas. I will show you the. Yeah, good evening, Deepak Kumar. Good evening. So today Vishwas Divas is going to start at 8 p.m. Most probably at 7:30 is going to be start. Right? Yes. Sir, what is the chatter frequency on the app? Hindi batch not available. No English batch not shown. Hindi batch only available. Beta, English batch is there, Vishnu. English batch is there. I'm taking the class. I have finished the class in English batch. I have finished the class. My last class, my last class in the app. I think it was my last class in the app is in the last Saturday. I have finished the English batch, my dear. Right, I have finished the English batch in the last Saturday. In the last Saturday, I have finished the English batch in app. So very soon the next batch is going to be start. Okay. No, sir. There is not showing any free English class on app. No, my dear, you will get here. You will get. Or what you do now, if you are not able to look, those who are not able to get, those who are not able to get the free classes, either they can contact the PW customer care number. If it is not possible to you, then you can contact me on my telegram. Okay, on telegram you can search my name. You will get Adityapal PW, right? And I will convey your message to our backend team. They will resolve your issue, right? They will resolve your issue. So don't worry, Alok Kumar, Vishnu. If you are not able to find the batches, please contact either to the customer care number. If it is not possible, then you can directly contact to me, okay, on my telegram group. I will forward your concern to the regarding person, right? Okay now. So what is the chattering frequency? Basically what happened now, first of all try to understand. First of all try to understand basically what happening. The tool is rotating, like, right? The tool is rotating. So what happened in during machining, some thrust force is acting on the tool. Some thrust force will acting on the tool, right? So when the thrust force acting on the tool, then it gets separated from the workpiece. But because of the tool post, because of the tool post, the tool again comes in contact with the workpiece like that. Again the thrust force come, it gets separated. Because of the tool post, it again comes in a contact with the workpiece. So during machining, that type of chattering will be happen. Is that clear? During machining, this type of chattering will be happen. Is that clear to everybody? Is that clear to everybody? What is chattering? Now I hope you understood the meaning of chattering. So what is going to be happen? Let's see the cross-sectional view. Basically, what is going to be happen? Let me show you. Let's say this is the workpiece, right? Let's say this is the workpiece, and you are doing a machining, right? You are doing a machining, right? You are doing a machining. You are doing a you are doing a machining, right? This is the machining that you are doing here. Please see. Now, what is going to happen on the tool? There will be a thrust force, right? And because of the tool force, the tool will go toward the workpiece. So because of that, the tool is hitting to the workpiece. Now, if you see the overall view, if you see the overall view, right? If you see this tool from here, right? This thing from here, then what you get, what you are going to see here, this is the workpiece, right? This is a workpiece which is going to be machined. And here, because the tool is hitting now, right? The tool is hitting. Because of that, what happened? Because of that, this type of indentation get happen. When the tool is going to hit, this type of indentation get happen, right? This type of indentation get happen. Are you getting my point? This type of indentation get happen. Yes or no? This type of indentation get happen. Yes. So please see, this type of indentation is going to be happen at the tool surface. This type of indentation is going to be happen. This type of indentation is going to be happen. This type of indentation is going to be happen. This type of indentation. Are you getting? All of you are getting? So the tool is hitting and this type of indentation is going to be happen. And this indentation is basically what? This angle is basically, this angle is basically this angle I'm talking about. This angle basically is what? 30 degree. This angle basically is what? 30 degree. The question is clear to everybody? The question is clear to everybody? Yes or no? Tell me. Is that question is clear to everybody? Yes or no? Now, he is asking that due to the indentation, that 30-degree angle is going to be what happen. So, in 500 revolution per minute, in 500 revolution per minute, how many chattering, how many hitting is going to be happen? How many hitting is going to be happen? Yes or no? This basically when the 500 revolution is going to be happen, then per unit time, how many chattering per unit time or per second, how many chattering is going to be happen, right? Is that clear to everybody? Please comment in the chat box. Is that clear to everybody? Please comment in the chat box. Yes. Is that clear to everybody? Please comment in the chat box. Yeah. Yes. Okay now. So this is going to be happen, my dear. Now, now Now the diameter and rotational speed is given, okay, 100 mm RPM. The highest spot chattering are found 30 degree spacing. Now, how many chattering, how many hitting, I mean, how many these type of spot is going to be happen in one revolution? In one revolution, in one revolution, in one revolution, right? In one revolution, how many chattering is going to be happen? 360. Basically that 30 degree per chatter, that indentation comes basically that 30 degree per chatter, right? So 360 degree divide by that 30 degree per chatter. So how many chatter you will get? This 30 degree per revolution now. This is 360 degree per revolution. In one revolution, how many degree? 360 degree. So you will get what? 0, 0 and 3, 1, 3, 2, 12, 12 chatter. My dear, 12 chatter per revolution. Yes or no? You are getting what? 12 chatter, 12 chatter, right? 12 chatter per revolution. Now, you are doing 500 revolution per minute. This is what? Per minute. You are doing 500 revolution per minute. If I'm going to write 500 revolution divided by 60, it is what? Per second. Yes. So in 500 revolution, how many chattering is going to be happen? 500 divided by 60 revolution per second. I'm trying to find out the frequency. Multiply 12 chatter, 12 chatter per revolution. So here you can see revolution cancel. So chatter per second, that is what? Frequency. That per second, that much per second, that much chattering is going to be happen. So here 500 divided by 60, answer into 12, that will be what? That will be 100 chatter, 100 chatter per second. 100 chatter per second will be the right answer, right? 100 chatter, 100 chatter, 100 chatter, 100 chatter per second. Okay, that chattering action per second, that is what? 100. So that is the frequency. Is that question is clear to everybody? Yes. Is that question is clear to everybody? Yes, tell me. Is that question is clear to everybody? Okay, everybody, no? Very good question. it may be possible that in upcoming gate exam this question may be repeat, right? It may be possible that in the upcoming gate exam this question may be repeat, right? This question may be repeat. Now, uh, let's in the last class, I think what we have discussed a shear plane. Now, now, let's discuss the cutting shear strain. Right. The next topic is today we are going to start, that is cutting shear strain. Okay, my dear. So here you can see the cutting shear strain. This is, you can say, the workpiece. Okay, which is going to be cut, and this is the shear plane. And here, let me make it draw. Let me make it bigger. Right. Let me make it bigger diagram. Let me make it a bigger diagram. Right. Let me make it a bigger diagram. Okay. See here. My dear, as you can see, this is a shear plane, and this is what? This is the tool, right? This is the tool, this is the tool, this is the tool, right? Now, the tool is here. Basically, this is A, this is A, this point. I'm talking about this point. I'm talking about this point. This is A. Is that clear? Is that clear? My dear, when the tool moves, right? When the tool moves from its initial position to this position, when the tool moves from its initial position to that position, are you getting my point? When the tool moves from its initial position, right? This is the initial position now. This was your tool, right? This was your tool, right? This was your tool. 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 Right. Now the new position of the tool is this. This is the new position of the tool. When the tool moves from B to this, then the deformation, just a minute, here this is what? This is A. The deformation, basically the chip will deform, na? The chip will deform in shear plane like that. So the B point will go here. That is what? B dash, yes or no? That is what? B dash, right? So in an equal amount, basically this deformation will happen here. The A will go here, that is at A dash, yes or no? That is at what? A dash, tell me yes or no? Tell me yes or no? Are Baba, tell me yes or no? Tell me yes or no? Yes or no? Right? Yes or no? So B dash, you can see that here A dash, A dash equal to B dash, let's say delta x. Let's say delta x, right? Let's say delta x, right? Let's say delta x. So deformation will take place. Deformation will take place from here to here. So this is a deformation. My dear, the thickness of this zone, the thickness of this zone, my dear, please see the thickness of this zone, this, right, and this, right? The thickness of this zone. This is what? Thickness of the shear zone. Okay, TS. TS is nothing. TS is basically what? Thickness of shear zone. Thickness of shear zone. Yes or no? Thickness of shear zone. Tell me. Thickness of shear zone. Yes or no? Thickness of shear zone. Am I clear? Thickness of shear zone. Yes. Yes. I mean, the deformation will be taken place in here, na? So this is what? Thickness of the shear zone. Now, I'm going to correlate this concept. I'm going to correlate this concept. I'm going to correlate this concept to the strength of material. Please try to understand. In strength of material, my dear, if you apply the shear force, right? If you apply the shear force, my dear, if you apply the shear force, right? So what is going to be happen? The deformation will take place, right? This the deformation will take place. This, right? Please see here. This was the deformation, right? In strength of material, if this is, let's say, A and this is B, after deformation, the point will be what? A dash and B dash, and the perpendicular distance, and the perpendicular distance, right? And the perpendicular distance, that is, let's say, what? L. So what is the shear strain? What is the shear strain? Now tell me, the shear strain, the shear strain will be what? Will be delta x by L. Yes or no? This was the shear strain you studied in strength of material. Yes, this was the shear strain which you studied in strength of material. Yes or no? Tell me please. Are Baba, tell me. You understood? You have seen this thing in a strength of material. Strength of material. Strength of material. Yes or no? Tell me. Strength of material. Yes. You have seen this thing in strength of material. Yes, na. So the similar concept I'm applying here, because you have seen that while applying the force, while applying the shear force, my dear, while applying the shear force, this is what? This is a shear force. Now you applied the shear force here, right? Shear force. So by applying the shear force, the deformation get happen. So this is the deformation A dash, A dash, B dash, B dash, and this is a perpendicular distance between this zone. So what will be the shear strain? Okay, what will be the shear strain? So shear strain will be delta x, okay, divide by delta x, divide by your thickness of the shear zone. Your thickness of the shear zone. This is the shear strain. Now tell me, is it clear to everybody? Is it clear to everybody? Yes. Is it clear to everybody? Yes. Yes. Is it clear to everybody? Tell me. Is it clear to everybody? Is it clear to everybody? Arey Baba, tell me, is it clear? Yes or no? Is it clear now? Is it clear now? So that's the same concept, right? This was the same concept. I think slowly students are getting, slowly students are decreasing in this session. They are shifting to the Vishwas Divas session. Am I right now? All of you are shifting to the Vishwas Divas session because slowly their students are decreasing in this session, right? Yes. If yes, then why are you shying? I mean, tell me. Yeah, because number of student decreases in this session. So I think the student wants to join the Vishwas Divas session, which is going to be start on YouTube at 8 a.m. Oh, sorry, 8 p.m. Today, 8 p.m. Right? Today, 8 p.m. Is it clear now? Is it clear now? Only 7 watching. Yeah, because they are shifting. They are going. I am getting your lecture. Okay. So I hope this point is clear. Now, so shall I move to the next point? So this is the thing. Now, my dear, velocities in metal cutting. Try to understand velocities metal cutting. Before that, again I'm going to draw this figure. Again, I'm going to draw this figure. Please try to understand again this concept, right? Please try to understand again this concept, please. Right, again. So this is the last topic which I'm going to discuss today, which is this is the last topic which I'm going to discuss today. Please try to understand this thing. Please try to understand this thing. Right? Please try to understand this thing. Right? Please try to understand this thing. Now, please try to understand, my dear. Please try to understand. Please see. Complete. Oh my God. Okay. See here. See. Look. when the tool, right, here you have seen that this is the tool, this is the tool, this is the tool, now this is the tool. Now see this point, try to understand here. Now, my dear, what is going to happen basically, the material will go from A to A dash. So basically, the material will go from B to B dash. So what is going to be happen? When you see the deformation will take place, the deformation will take place along the plane. The chip is deforming along the plane, right? The chip is deforming along the plane, right? So this is the deformation which is going to take place, and here you can see that it is delta x, same, it is delta x, and it is ts. My dear, here try to understand this point very clearly. Now this deformation, here shear strain basically is what, delta x by thickness of the shear zone. Okay, now my dear, once the deformation will take place, once the deformation will take place, see, oh my god, once the deformation will take place, then what is going to be happen? First of all, deformation will take place, then after, what is going to happen? The chip will move, the chip will move in the upward direction, the chip will move in the upward direction, yes or no? The chip will move in the upward direction, yes or no? The chip will move in the upward direction. So after deforming in this plane, after deforming in this plane, the chip is moving, okay, in a upward direction. And when you notice, when you are sitting on the tool, when you are sitting on the tool, yes or no? So my dear, the velocity which you are observing with respect to tool, this is the chip velocity, and the velocity of the chip which you are observing from the workpiece, the velocity which you are observing from the workpiece is known as what? Is known as your shear velocity. And if the workpiece is moving toward the, if the workpiece is moving here, you please see, if the workpiece is moving, if the workpiece is moving toward the tool with a cutting velocity v, right? So v is nothing that, v is what? V is what? Let me write down here. V is cutting velocity. Here v is cutting velocity, right? Cutting velocity. That is nothing that, it is nothing that, it is the velocity of workpiece with respect to tool. Vs is nothing, it is a shear velocity, it is a shear velocity, it is a shear velocity, right? That is what? Velocity of chip with respect to workpiece. Is it clear? Because you are observing that deformation with respect to workpiece, yes or no? Now VC, VC is chip velocity, VC is what? Chip velocity, chip velocity, that is what? Velocity of chip with respect to tool, yes or no? So these are the velocity which are relative to each other. If you draw the diagram, this is the cutting velocity. Here you can see, this is what? This is the cutting velocity V. This is what? This is the shear velocity. That is what? That is a shear velocity. Let's say it is what? It is the Vs. This is what? This is the chip velocity. This is the chip velocity, my dear. This is what? This is the chip velocity. My dear student, please make the normal. Please make the normal. This is a reference line or normal line. Here the chip is moving. Here the chip is moving. Here the chip is moving in this direction, right? In this direction. With a chip velocity, what? With a chip velocity VC, and it makes an angle alpha from the vertical. So similarly, you can write that chip velocity makes an angle alpha, makes an angle alpha, makes an angle alpha from the vertical reference line. Here VS makes an angle what? Makes an angle phi from the horizontal, from the horizontal. Is it clear? My dear, this is what? This is 90 minus alpha. This is what? This is 90 minus phi minus alpha. Is it clear? Now all of you know the sine rules. All of you know the sine rule. What is the sine rule? Sine rule is very simple. V divide by sine of this. V divide by sine of 90 minus phi minus alpha bracket close. Vs divide by this. Vs divide by sine of 90 minus alpha Vc divide by sine of phi. Yes or no? Yes or no? Yes or no? Tell me. Yes or no? Tell me. Is that formula is clear? Is that formula is clear? Is that formula is clear? Yes or no, my dear? Tell me. This is a very, very important for your gate. Very, very important for your gate. Is it clear? Is it clear? Okay. So now I'm going to stop the session because at 8 p.m. Vishwas Divas is going to start on YouTube session, right? Either you can see this session on Gate Wallah, Physics Wallah, any channel. This session is going to be live within a few minutes, right? So enjoy the Vishwas Divas, my dear. It will be a great session. Okay, this is a live session. So thank you very much. We are going to meet tomorrow. Okay, bye.